Section 7 is stream channels. So we have two types of the channel that we're going to look. First is going to be bedrock channels, and the second we'll talk about the alluvial channels, and I'll let you watch a video here. So bedrock channels, where you see this rapids and waterfall for features. So if you are taking the lab section for this class, that's important for you to kind of distinguish which kind of features are related to which kind of channel development. So bedrock channels are cut into solid rocks and are most common in headwaters area where the gradients are steep. So where actually the channel starts is going to be the bedrock channel. So as you go down from a hill, you will reach out to alluvial channels where you have the alluvium. The sediments are mostly loosely and consolidated sediments. They are dominated by stream flow through alluvium previously deposited by the stream. A floodplain usually covers the valley floor, with the river meandering or moving through braided channels. And the braided channels picture is going to be in your PowerPoint slides if you don't have the book yet, so you can find out how they actually look. Another feature that it's really important to understand this development, the meanders. You need to understand what does meander mean and what kind of key terms related to meander. Key terms related to meander is cut bank, point bar, cut off, oxbow lake. Okay, these features are seen in the meander stream shape, right? So meander change shape through erosion at the cut bank, and those are where the outer edge of the meander and the deposition of sediments on a point bar, which is located in the inside of a meander. A meander may become cut off and form an oxbow lake, and I will let you watch the oxbow lake evolution too. First, let's do the oxbow lake here.
Through time, meanders change shape, causing a neck of a meander to gradually become more narrow. Eventually, the meander is cut off, and this process shortens the stream and creates an oxbow lake.
As you see in the video, you can see a real picture at the end, and I would like you to watch this video in order to understand better and visualize what is the cut bank and what is a point bar. And if you're taking the lab section, these features are really important if you're doing a lab report.
Hello, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the physical processes that result in the meandering of rivers and streams. So this is what meandering looks like. Look at this crazy loopy path that's being taken by this river here. It goes all the way over here and then back around and then over here and then back around and over this way. I mean, that's just a pretty extraordinary shape. What's the reason for that? Well, let's take a look. Here's a house, and this house is perched on the edge of a fairly precarious looking cliff. That house is sort of set up like this in this diagram down here. You can see the house perched on the edge of the little cliff there in the upper right. Notice that there's a river flowing down below it, and as that river meanders across that valley, the highest velocity water in the river channel shifts from side to side. Let's go ahead and draw two cross sections through the river right there and see what the velocity structure looks like in those two different locations. Okay, first off, in the straight channel, you can see that the maximum velocity is right there in the middle, versus where the channel curves around a bend, the maximum velocity is over towards the edge. It's almost like if you're driving a car around a bend in the road and you're going a little too fast, your body gets pulled towards the outside edge of the curve. Basically, it's all about momentum. And so that ends up being the same thing going on here. You end up having more water energy over on the outside of the curve, and that means that there's less water energy over on the inside of the curve. So if we go back to our main picture here, we'll notice that there's erosion taking place on the outside of the curve, and there's deposition of new sediment on the inside of the curve. We call the outside of the curve the cut bank, and the inside of the curve is the point bar. Here's an actual photo of the real thing in nature. You can see that the river current is coming from the top of the screen down towards the bottom, and as it's flowing along, it ends up curving around the edges. That ends up basically resulting in lower water velocity on the inside of the curve. That means deposition takes place there, so we've highlighted the point bars in red. And then erosion takes place on the outside of the curve, these areas that are highlighted in yellow. If erosion on the outside of the curve ends up lining up with erosion on the outside of another curve, the curve itself can end up pinching off. So you can end up actually cutting off loops of the meanders, and those will become new oxbow lakes. So that's shown here in this picture, where you've got erosion basically cutting through a narrow little neck here, and that means that this whole channel ends up being abandoned. That becomes this sort of U-shaped lake called an oxbow lake. So where does that leave us with regards to the meanders that we started in the first place? Well, if you let this system run a little while longer, probably what's going to end up happening is erosion on the outside of that curve and erosion on the outside of that curve are going to remove that narrow neck of land. And that's going to mean that the river channel is going to have a shorter path to the sea, therefore a steeper gradient, and its old meander loop is going to be abandoned to become a new oxbow lake. Hope you got that. Thanks very much for your attention. This has been another Smart Figure.